everybody. As you may notice by my name, I'm not Polish. I come from Spain. I'm a software engineer right now working for VMware, which was Vietnamese a couple of months ago. Let me talk a little bit more about me. So yes, I'm a software engineer working for Vietnamese, which was acquired by VMware this summer. I'm the technical lead in the Kubeless project. That's what brings me here today. But I'm also working on different projects. I will tell you about them in a minute. I'm certified Kubernetes application developer. I mostly work on Kubernetes applications, the whole range of applications. And I come from the beautiful Seville in the south of Spain. If you are looking for places to go on vacation, you should really consider Seville. It's beautiful. So what's about Vietnamese, VMware, and Kubernetes? We come from this, in Vietnamese, from this open source application catalog. So we have been maintaining for a lot of years now a huge catalog of open source applications, but for virtual machines. Once the whole container world is evolving, we have been pretty involved with that, and we are right now the official maintainers of 30 stable Helm charts. Have you ever worked with Helm charts? Cool. So apart from that, we have more than 150 open source applications. We have made them containers, and they are available for free. And one thing to mention is that these applications are tested and are up to date in every single cloud. So if you want to use Google Cloud, Azure Cloud, all the tier 1 clouds, you will find our images there. But it's not only that. We have several Kubernetes applications that we develop, and that all of them are open source, so you can use them. They are all on GitHub. First of all, Kubeless. This is the project that I'm going to talk today. But there are several ones like KubeApps. The people that have worked with Helm, you may know this tool. This is a web UI, kind of a web UI for applications in Kubernetes. It's pretty cool. It allows you to deploy, rollback, all the management of the application, but in Kubernetes. I'm going to talk about this tomorrow in the Helm Summit in Amsterdam. So if you're there, just say hello. We also have something called Sales Secrets. This is a pretty cool project because it allows you to store in GitHub secrets. Okay, there is a way if you do that in a secure way. So you just need GitHub and you can store everything in GitHub. And also BKPR. That is a set of tools that you can install, and from zero you can have a production-ready cluster in a matter of minutes. It's really cool. It's just one command, and you're ready to go in different clouds like GKE. But we're adding all that value to VMware that since the acquisition of Ectio has a really big presence in the Kubernetes ecosystem. We have Joe Vida, that is one of the founders of Kubernetes. So yeah, we are really into Kubernetes. So if you have any question about Kubernetes, not only serverless, I'm the guy to go. But let's talk about Kubeless. Okay, kubeless.io is the webpage. That's a GitHub repository. Kubeless is a Kubernetes native serverless framework. This means that you can use Kubeless to deploy your small bit of code without needing to worry about the underlying infrastructure structure. This is more of a function as a service rather than other thing. But let's get a glimpse of its features. As we say, this is Kubernetes native. This means that we are not reinventing the wheel. Every single aspect of Kubeless is mapped to a Kubernetes entity. So the only thing that we have implemented is this kind of layer, abstraction layer, in which a function is then mapped to a deployment, for example. It's just everything is Kubernetes native. We haven't implemented anything apart from this layer. It's cloud agnostic because you can run Kubernetes everywhere. Another important thing is that this compatible, is supported by this serverless framework. If you have worked with Lambda, you may know this useful framework that basically allows you to deploy several applications, several functions with one command and and do certain things, which is really useful. So if you have that, you can easily migrate those to Kubeless if you want. Also, we have multiple languages and multiple triggers, but I'm going to talk about that later, so let's continue. Before I move on, I want to clarify some of these concepts because I really want you to understand how Kubeless works. It's really simple, so it's important for me to introduce you with this knowledge. First of all, custom resources, definitions, and controllers. There have been several talks in this conference about this. Everyone knows what that means? What those are? Okay, so these are the native way of extending Kubernetes. So for example, if you want to have a new type of object in Kubernetes, like let's say a cron job, you define a custom resource. And you say, okay, a cron job has some specification that is going to be the schedule, for example. Then when you create a custom resource, the controller is the one that is going to read it, is going to notice that, hey, something changed, let's do something. And that something is a blank page. You can do whatever you want. And then the last thing I wanted to mention, probably every one of you know, but the distinction between a function and a trigger. Okay? The function is just the code that you want to run, while the trigger is whatever triggers the function. Let's say a message in a queue or a GitHub hook, or that kind of things. So once you have this clear, let's see how Kubeless works. It's really simple, as I said. The only thing that you need to know is that there is a function custom resource. So let's see, you have a function, which the only thing that it has defined is that it's going to return a hello world. This is going to be read, it's going to be watched by a function controller, and this function controller is going to act in consequence. This means that it's going to create a pod, a service, a deployment, whatever is needed, depending on the specification of the function. And the same thing for all the triggers that we support. If, for example, you want a schedule trigger, you only need to define the schedule, like, for example, every minute, and the trigger controller is going to act in consequence and create, for example, the cron job that is needed to run a pod in a certain schedule. That's all. If you understand this, you understand how Kubeless works. It's really simple. So let's see. I have plenty of demos, so I want you to be very focused because I'm likely to make some mistake. So, well, one thing first, I have all this demo in this GitHub repository, so if you want to follow them afterwards, you can do so. So let's go to the first demo. The first demo is very simple, and what I'm going to do is install Kubeless. I'm going to deploy a function, and I'm going to execute it. For helping me, I have a script for every function. Can you properly read this? Yeah, cool. So installing Kubeless is really simple. It's just creating a namespace and then apply a manifest. Let's do that. And I say that Kubeless is pretty lightweight because if you go to the namespace, you see here that this is everything I'm going to install. It's just a deployment with 3 containers, and that's all. You are ready to go. So let's deploy a function. I'm going to, well, let's see first the function. It's a very simple Python function. It's going to return the hello world, as you said. So let's deploy it. First, it's going to create a namespace because I'm tidy, and I want the function to be deployed there. It's really simple. I just specify the file. I'm going to specify the name of the function, that is hello, the namespace, and the runtime. In this case, I'm using Python 3.7. So if I check the namespace, here it is. It's running, so it's really easy to call them. So notice that this is actually using the internal service in the cluster, so you cannot reach it from outside. This is just because I haven't created any trigger. The only way of calling this function is going inside the cluster. So hopefully you have all followed. Let's talk a little bit about runtimes. I really like how Kubeless manage those runtimes because it's really easy to add one. The only thing that you need to do is kind of create an HTTP server and load a function dynamically. That makes us to be able to differ between two groups of runtimes. Ones are the stable ones, which have several features like metrics, like timeout handling, like several different features that you can trust, while having some incubator ones that are for people that are just creating their new runtimes and adding new features. So for the stables one, we have the most popular ones: Node.js, PHP, Python, Java, Golang, .NET, Ballerina, that is a cloud-native runtime language, and Ruby. And then for the incubator, we have several virtual machines, Java-related languages. So for example, we have a distro-less Node.js version, which is the same Node.js, but without distribution. It's pretty cool. So let's see a little bit closer how a function looks like. If you can see, this is a pretty simple function, and every function receives two parameters. One is the event, the other one is the context. The event is just the information related to whatever triggered the function. Like, let's say, here you have an example of an event. Let's say there's an event which body contained an object which was foobar, and then you have all the information related to that event, like the unique ID or who triggered that event. It's really useful. And then you have the context. The context represents the environment in which the function is being executed. Like, for example, the name of the function, the timeout, the runtime, or the memory that that function can consume. If you notice, this is pretty similar to Lambda functions, which has the same structure of parameters. So you can do similar things. But let's talk about triggers. By default, you can trigger functions using HTTP. That's pretty common. Then cron jobs to do that in a scheduled way, every minute, every hour, whatever. But then you have other type of triggers that are a little bit more complex, like Kafka and NATS. Those are pops up mechanism in which you send a message, the message is in a queue, and eventually it's consumed. And Kinesis. Kinesis is a stream solution made by AWS that's also supported. Those three are not included by default because they are a little bit more, they are not so light, and you may not want to use Kafka, so why include it by default? If you want it, it's really simple to install. So let's talk a little bit about how you can expose a function. This is also called creating an HTTP trigger. It meaning that you're able to launch or execute that function using a HTTP endpoint. And as I said, we're not reinventing the wheel. At the end of the day, what we are doing is creating a Kubernetes ingress object. Do you know what a Kubernetes ingress object is? Okay, it basically allows you to have an endpoint, a public endpoint, so you can hit it from everywhere. You don't need to be inside the cluster. So right now, we support officially 3 different ingress controllers, which are Nginx, Traffic, and Kong. But in theory, you can use whatever. It's just a matter of having an ingress controller. And the cool thing about this is that allows you to use TLS with a certificate or even authentication. So you can control who can access a function. But you don't have to believe me. I have a demo. So let's go to the second demo. Let's go to the script. This is quite big, but what I'm going to do here is the same thing that before. I'm going to create a function. I'm going to deploy a function. This time it's going to be a Node.js function. And this Node.js function, what it's going to do is to return the headers of the request. Nothing really complex. Then, as I said, you need an ingress controller. I have already enabled it, so it's cool. And this is my, I'm going to access it using a user password. My user is going to be Andres, and the password pass123. And I'm going to store that as a Kubernetes secret, so it's properly secure. Apart from that, I'm going to create a certificate, so I'm able to access that function using TLS, using this certificate. That's really useful, so I can use HTTPS. This is where the trick comes. I'm going to store in my etc host the host name, which is demo2.com, and obviously I don't have. So let's do everything. I don't need to do that. Okay, I have created all the secrets. And let's deploy the function. The function is already deployed. So the only thing that I need to do is create the HTTP trigger. Okay, if we take a look to this, I'm going to specify a host name, the namespace, but I'm going to specify the secrets they have created before in order to have this username password, and not only that, but the TLS secret that contains all the TLS certificates. That's really useful. So let's execute everything. Here you have everything in the namespace demo2, which is the deployment, the typical deployment. But here is the ingress that has been created along with the with the function. So actually, I think that should work. So let's go to Chrome. Let's open a demo incognito window. Okay, here is giving me an error because the certificate is self-signed. You cannot add a certificate in Chrome, at least not easily. But I can proceed. Now I only need to use my username and password, which was exactly. And here I'm using TLS, I'm using HTTPS, and I'm able to access the function, which is my headers right now. So that's cool. Let's continue. What else? I have mentioned before that we have support for several trigger types. One of them are PubSub mechanism. And for this, we have Kafka and we have NATS. NATS is a CNCF project. It's also under the CNCF. And it allows you to do kind of the same thing with Kafka, but I think it's a little bit more lightweight, just about sending messages in a queue. The workflow is very simple. You send a message, you publish a message. Kafka or NATS are going to receive it, and they are going to be redirecting that to Kubeless. The same for the streams, but you need to handle Amazon Kinesis. So let me do a really quick demo of that one. In this case, as I said, I need to install Kafka. And the only thing I'm going to do is create a topic in Kafka. This is not related to Kubeless, but we have a helper. And I'm going to publish some content that is hello world. Then I'm going to deploy my function and the trigger. This is the new thing. Here, instead of the name of the function, you can use a function selector. This is kind of a label selector. So in case you want to not trigger just one, but several functions, you can do so. So let's deploy everything. Yes, yes, yes. That's it. There is something not real. Let's go. Cool. They said Kafka has several things, so that's not included by default. I guess that's already running. Yes. So I can create the topic and publish something. Well, first of all, I think I need to deploy this. This is the function. The function is really simple as well. It's just a Node.js function that is going to print the message. OK, I have received a message. This is the content. Yes, I have deployed that. Let me deploy the trigger, which is not demo topic. It's just demo3. I think this has created the topic, so the first one is going to fail. This is where the error comes. Here I'm missing some quotes. Yeah, the topic is already created, so it's giving me an error, but I can publish. And now, if we go to the logs, demo3, my pod. Oh, it's not working. So yeah, I have several. I don't know. Kafka is behaving funny today. Anyway, you can believe me that replication file larger than available brokers. Okay, that's cool. That's an error from Kafka, so okay, I don't have time to debug this, but you can believe me. Another thing I wanted to mention, autoscaling. It is important for serverless to have autoscaling. If not, what kind of serverless platform it is. For this, we are using horizontal pod autoscaler, which is a feature in Kubernetes that allows you to, based on certain metric, let's say CPU and memory, those are the typical ones, but you can define a different one, like, for example, queries per second, or, I don't know, you name it. With this, you can create these autoscaling rules and be able to scale your deployments horizontally. I also have a demo for that, of course. So for this demo, what you need to have is metric server and Hipster. These are the tools that allows you to know how much resources a pod is consuming. Those are dependencies. And I have already enabled them. And let's see an example. Let's see the function first. OK, in this function, what I'm going to do is infinite loop, taking math random, that if you don't know, that's a heavy function. So hopefully we're going to consume the resources of the function. So let's do everything. Here you can see the resources that my pods are consuming right now. It's really low. As you can see, they don't have traffic, so you only are consuming like 20 megs of memory and no CPU. But if I deploy my ugly function, we're going to give it some requirements and limits. Let's say that this function is only allowed to consume 100 millicores and 50 megs of memory. So if we do so, here we have our function. And now let's autoscale it. In this case, I'm telling, OK, use CPU as the metric. And I want a minimum number of 1 pod and a maximum of 3. I don't want this going crazy and consuming everything. And also I'm telling it, OK, if the pod goes over 20% of CPU usage, then you spin up another one. Cool. You can get the horizontal pod scaler of the demo. And you can see here that we have this horizontal pod scaler. So let's, I think I have deployed the function. Have I? Yeah. Let's call the function several times. This is hanging because it's just calculating random numbers over and over again. So if I do now top, if I'm able to write, and I forgot to put, that's it. Here you can see that the consumption is growing. So if we go to different terminals and we get the pods of that namespace, eventually, whenever it's detected that over 20 milli CPU cores are being used, it's going to spin up two additional pods. It's going to last for some time. Once the cluster comes back to their normal state, let me call it a couple of times more. Give it some trouble. So yeah, here we have. It is already over the limit, so now it's spinning up the new pods. And now I'm going to have 3 different pods for sending this request. It's really useful. So OK, that's really cool. Let's continue. This is one of my favorite features of Kubeless, sorry. Because every time that you need to deploy a function, let's say that you have some, if it is a Golang function, you have either dependencies that you need to install, and then you need to compile everything. You need to compile your function. You need to compile your dependencies. And if you add up all that time, it's going to be quite some time, let's say, under a minute to deploy something. If you're going with this to something close to production, you want a function every time that you need to scale up and down to be really quick. And for doing so, we have this building function feature that the only thing that it does is once a function is ready, it stores it as a Docker image in a Docker registry. So every time that you need to redeploy that function again, it's just going to use that image, and since it's already in the Kubernetes cluster, it's going to be really fast, like 2 seconds, 1 second to deploy any function. And I have a different demo. In this case, as I said, this is a Golang function. It's going to return a hello world, but it needs some compilation, which takes some time. So the thing that I'm going to do is to create my Docker registry, my Docker Hub credentials as a secret in the cluster, and I'm going to enable this feature in Kubeless. So let's do this. As you can see, I'm using some demo credentials, which are not true. OK, so for enable, it's as simple as enable the build step here. True. And then you delete. It should be there. I don't have to write it. Here you have. If I delete my controller, it's going to reload the configuration, so I can deploy the function. Yeah, I can deploy the function, and you can see demo 5. In 1 second, 2 seconds, this is not compiling the function, but it's pulling the function from the Docker registry. If we check the logs of the controller, let's see how it's there. What's there? Is the function controller. Why? OK, I forgot the prefix. Here we should be able to find here. Found existing image. So since this has been already built, it's only reusing the image, so it's not compiling and doing all that hard work that takes so much of your precious seconds. So that's the simple demos that I wanted to mention. One thing is that since all the stable functions provide this metrics endpoint, you can plug in some tools like Grafana, like Prometheus, and out of the box, you're going to have metrics for those functions. You're going to see how many times that function is being called, how many failures, how much time does it take for them to be executed. You know, all that useful information that you can get with a pretty dashboard. OK, so what else? One more final demo. This is a little bit more complex. What I'm going to do now is to deploy a to-do application. This to-do application is going to be backed up by several functions. One is going to be for creating a to-do item, for delete them, for read them all, and you know. And everything is going to be stored in a MongoDB database, and I'm going to be able to access it through a simple React application that's going to be outside the cluster. So let's go. Let me clear this because it's already messy. I have two folders, one for the backend. And for doing this, since there are several functions, several things that I need to deploy, I have this serverless.yaml. This is a serverless framework YAML that you may have seen some before, in which I'm able to define everything I want to deploy. And not only that, but I'm able to deploy that with a single command. Okay, this is going to package everything. Okay, I forgot to create the namespace. It's going to create everything, the ingress rule, the functions, everything that I need. Let's see an example of a function because it's interesting to do up. Let's see, for example, the create. Backend create. So the function, what it's going to do is going to connect to MongoDB. It's going to get the data from the event itself. It's going to store it in the database, and it's going to return the JSON of the object. So everything is ready in the backend. To do up. Okay, everything ready, everything cool. Let's deploy, I think it's here, the command. Yeah. Let's deploy MongoDB. I'm going to do this with a single YAML. Okay, this is not here. Cool. This is going to deploy MongoDB. This is going to be the backend for the data. And I think we are done here. Let's go to the front end. The front end is a React application, which is going to be running in my cluster. It's just a very simple React application. So npm start. It's going to compile all the assets. And hopefully, let's cross finger, this is going to work. So for accessing this React server is going to start in localhost. So let's go to localhost 8080. And let's see. You're seeing me debugging live. Error 9 not resolved, which means that either my minikube IP is not correct or I missed something. Yep, that's correct. The ingress rule is there. Could be. No, not really, because this is just the backend. This is what is internally calling. It's not really. Yes. This chip.io is a service that allows you to redirect using IP. It's really useful. So what else can I check? Maybe I forgot some function. I don't think so. I don't really know. Okay, so I have a backup, which is a video which is not here. Anyway, that's a pity. But in theory, you can create here. Oh, that works. So probably the read all function is not working, but the other ones are. So you can create a to-do application. And you can delete it. That's really cool. You can deploy some things really simple. The demo codes were not with me this time, but hopefully you get the idea. Hopefully you get how simple and how easy it is to manage serverless thing on Kubernetes. So I think that's everything I wanted to show you. So let's open for questions. People usually ask me, how is this different from Knative? Why should I use this instead of Knative? The answer is that these are different tools for different things. Knative is meant to be like a framework to create applications. It's not a function as a service. So just it's really useful and it's really complete. But if you want to do simple things like create a very simple function that is going to be there, it's going to be ready in a few minutes, and you don't have to install a ton of things in your Kubernetes cluster, you may go for a simpler solution. But as you can imagine, everything are tools in your toolbox, so you can choose wisely whatever you prefer.
And on the other hand, could you compare it to Lambda or other function as a service, public services?
Yeah, the good point about this is that you can deploy that in your on-premise cluster. So you both don't need internet access if you don't want to, and also you can deploy it in your on-premise cluster. You don't need to delay on either a provider and have some kind of vendor lock-in on that kind of stuff. That's why you may choose a different tool. It's not that it's better, it's worse. It's just a different tool for a different use case.
Can we deploy this on managed Kubernetes cluster on GCP, for example?
Sure.
And the second question, can I just move code from Lambda or AWS instance just to put it without any modifications? So 2 questions.
Yeah. The first question, yes, you can deploy this in every single Kubernetes distribution. Let's see, GCE, GKE, AKS, EKS, all the KS that you can imagine. Because at the end of the day, this is just Kubernetes. It's not anything else. And answering the second question that was, sorry, can you repeat? Yeah, move code. That depends on the use case. Like, for example, if you have a function that is relaying in Lambda, that is relaying with Lambda gateway, or is relying on Cognito, that kind of typical things, then you cannot move that out of the box because obviously you have other dependencies. But if it is a function that is self-contained, then sure, why not?